Hello, it's Dr. Mears, and today we are going to be multiplying complex numbers. First, a little review of inverse operations. The definition: inverse operations are two operations which are exactly opposite. That means one undoes the action of the other. We know addition and subtraction are exactly opposite operations. Addition and subtraction undo one another. So does multiplication and division. The third one, taking the square and then taking the square roots, are also inverse operations. And this is the one that we're going to look at right now, which will help us to multiply complex numbers. An example. So first, let's take the example of squaring 2. Okay, so we have 2 squared. That means 2 times 2, which is 4. Okay, if I take the square root of 4, you're right, I get back 2. Now I'm not solving here, so I don't need those two answers. I don't need 2 and negative 2 right now. We're just talking about positive numbers, staying the positive numbers, just so that we understand square and square root and how they're inverse operations. A second one could be, we could do the same thing. 3 squared equals 9, and then the square root of 9 is 3. So it undoes the other. We could also write this as the square root of 3 squared. Okay, so the square root of 3 squared. Well, what happens here? We have the square operation, and we have the square root. And they are inverse operations, meaning they undo each other. And so we're just going to get the number 3. We did the work here to show that that actually works. We can go back and do the same thing for number 1. We could take the square root of 4 squared. Inverse operations, they cancel each other out, and so this is just going to be 4. All right, let's look at the square root of negative 1 squared. Okay, I think you're catching on. Inverse operations, they cancel each other out, so this is going to be negative 1. Now, if we want to deal or if we want to work with the symbol I, remember, I equals the square root of negative 1. And since I equals the square root of negative 1, if we square I, we're looking at this example right here where we're squaring the square root of negative 1. So we're just going to get out negative 1. And this is what we're going to have to remember and take with us, that I squared is equal to negative 1, because these two are inverse operations, so they undo each other. Knowing that, let's move forward with multiplying complex numbers. All right, first a little warm up here, simplifying each expression. Before we start to simplify expressions with complex numbers, let's just review the distributive property and simplification of our expressions. So here we have negative 2 times the quantity negative 7x minus 8. So I'm going to distribute, which means I'm going to multiply the negative 2 by what's inside the parentheses. So negative 2 times negative 7x gives us a positive 14x. Negative 2 times negative 8 gives us positive 16. These are not like terms, meaning if these were, this would have an x. These are not alike, so I stay there and I don't move further. Here I have negative parentheses a minus 1. That's really a negative 1 times the quantity a minus 1. So we're going to just distribute that negative, multiply it. So negative 1 times a is negative a. Negative 1 times negative 1 is positive 1. Not like terms, we leave it and move on. Number 3. I have two expressions being added together. We have 5 times the quantity 9r minus 7 plus 2 times the quantity 4r minus 6. So let's just first take care of that expression right there. So let's distribute. 5 times 9r is 45r. 5 times negative 7 is negative 35. I like to cross things out, meaning we just now need to look at the second one. Positive 2 times 4r is positive 8r. Positive 2 times negative 6 is negative 12. And now we see here we need to combine like terms, So the first two terms I'm going to combine are going to be 45R and 8R, and 45R plus 8R gives me 53Rs. And then I'm going to combine negative 35 minus 12, and that gives me a negative 47. These are not alike, so this is my answer right here. And for number 4, we're going to approach it the same way. First, looking at this first one here, negative 7 times p is negative 7p. Negative 7 times positive 5 is a negative 35. That one's done. Negative 10 times positive 3p is negative 30p. Negative 10 times positive 10, negative 10 times negative 10 is a positive 100. Okay, now let's combine like terms. 7p and minus 30p is going to give us negative 37p. And negative 35 plus 100 is going to give us a positive 65. There are no more like terms, so I am just going to leave it. Okay, next, we are going to be multiplying complex numbers. So a couple notes here. To multiply two complex numbers, we can use the distributive property or the FOIL method. And we practiced this before. It's the same thing. So let's just recall what it means to use a distributive property. We did it here in 1 through 4, but we're going to do it using an example. And so we have 2 times x plus 3. And so to distribute, we distribute 2 times x, which equals 2x, and 2 times 3, which equals 6. So, that's a distributive property. We also can use FOIL, and that comes when we have a binomial. So binomial is when we have 2 terms in the first set of parentheses and 2 terms in the second. So I am going to use FOIL with this, and then I can also use the distributive property. I can go back to that. So let's use FOIL. So FOIL, the F, O, I, and L. F means first, O means outer, I is inner, and L is last. So what do I mean by that? If we look here, our first term in this set of parentheses is A. The first term in this set of parentheses is C. So it's going to be A times C. Okay, that was first. Okay, outer. If we look at this whole thing, my outer term is A and my outer term is D. Kind of like if they're all in a row, these are on the outside. So that's going to be plus A times D. All right, my inner terms, well, if these are the outer terms, these are my inner terms, so plus B times C. And then my last terms, yep, you guessed it. We're just now looking at just this first set. This is my last term. Second set, this is my last term. So it's going to be L times L, so plus B times D. Now it's much easier to do an example with FOIL. So let's do example with FOIL. I'm just going to make a little. Let's do x plus 2 times x plus 5. So our first term would be x and x. Those would be our first and first. So that gets us x squared, okay? My outer terms are going to be O, outer, and outer. So x times 5, which is 5x. My inner terms, inner and inner, plus 2x, and my last terms, 2 times 5, which is 10. I forgot my x there, so just be careful. Now we have like terms, 5x and 2x are alike. So I'm going to do x squared plus 5x and 2x is 7x plus 10. There's no other like terms, so that is my final answer. Now, how about if we use double distributive? What does that look like if we use double distributive? And so that's just using the distributive property twice. So that's doing what we did here, but in this type of example. So what does that look like? Okay, so we have x plus 2 times x plus 5. So the first thing that we would have to do is just focus on that x. So it just looks like this. So we have x times x plus 5. So let's do x times x, which is x squared, and then x times 5, which is 5x. Then you can just get rid of that x. It's all gone. You did it. You distribute it. It doesn't exist anymore. Now we have to do the distributive property again. So then we have to do the 2 times x, so plus 2x, and 2 times 5 plus 10. So here's our second distribution. And then just like we did over here, let's combine like terms. I'm going to get x squared plus 7x plus 10, which is exactly what I got over here, but this one I did the double distributive. So either way you want to multiply, whatever you find the easiest, then that's the way that you go and do it. Okay, next. And this looks a little hazy, so I'm just going to refocus my camera right here, everybody. That is much better. Just a little refocus. All right, so we're going to use either the distributive property and or the FOIL method to simplify the following expressions. And what we have to remember here is about our I squared, and also how to write the answer out. So we need to make sure that we know that I squared is equal to -1. So we need to keep that in the cloud in our head. I squared is equal to -1. We also want to write the answer out as, I'm going to put this right in the middle over here. It's going to be the real number, A, and then the imaginary number plus or minus BI. So you can either have A plus BI or A minus BI. So let's see what that looks like here. I'm especially learning about this. Okay, so we have 4i times a quantity -6 plus I. So let's use the distributive property. So 4i times -6 is -24i, just like we were doing above here. 4 times positive I is a positive 4. I times I is I squared. And so here's where a couple of things have to happen. First, we're going to have to change that I squared to -1. So I'm going to do -24I plus 4. And now this is times I squared. So it's times -1. And so what's a positive 4 times a -1? It's going to be -24I minus 4. So if you want to think about it as if you have an I squared, this sign is going to change to its opposite. You could think about it like that. Once you get going in these problems, all of a sudden you say, oh, I squared, that's now going to change to minus, and vice versa. However, we have to write it where the real number is in front. So the real number here is -4. So that's what we have to write first, -4. And then comes the imaginary, so -24i. And so this is how we multiply complex numbers, making sure we use I squared. Bennett, now everyone's going to hear that. Okay. And write it out as a plus or minus BI. Okay. So just one answer here. We're not solving, just one answer. This just happens to be minus. All right, number 6, let's use double distributive, and then we can use FOIL. So let's just concentrate on the 9 here. So we're just going to distribute 9 times -4 is -36. 9 times positive 7 is going to be I, is positive 63I. So now the 9 is done. -2 times -4, -2i times -4 is -8i, and -2 times I times positive 7i is going to give us a -14i squared. Okay, now if you're thinking I want to concentrate on that first, you're right, I squared is going to become -1, so this will become positive 14. So all I did was I just did -14 times -1, which comes out to be a positive 14. And again, you can think about it as just flipping that sign. Absolutely fine. Okay, do we have like terms? 63 minus 8. Actually, this is a plus 8, my bad. Negative times a negative is a positive, just be careful. So we can add these together. 63i and 8i is going to give us 71i, and then plus negative 36. Now, there are other terms here I can combine. These two are like terms. So it's almost like you just have a couple more steps when you're multiplying. When we were using x's and a's, like we did above here, we didn't have as many extra steps. It's, you do have to take care of some of these extra steps. So negative 36 plus 14, that is going to give you a negative 22. This and this, negative 22 plus 71i. And we did write it in a plus bi, so we are good to go. And that's what you get when you multiply. Okay, let's try number 7. So let's do our first. So here we have our first is 4 times negative 4, so that gives us negative 16. Outer, negative 4 times negative I, positive 4i. Inner, 7 times 4, positive 7i times 4, positive 28i. And last, 7i times negative I is negative 7i squared. Okay, so all of a sudden, if you see that I squared minus 7i squared, yep, we can change that just to a positive 7. We can combine the 4i and the 28i. We do get 4i plus 28i is 32i. And don't forget to bring down your minus 16. Yes, one more step. We have minus 16 and minus 7 is going to give us a negative 9 plus 32i, and that is our answer. Okay, so making sure that we're combining our like terms after we are finished. Now, if you want to try number 8, either way, using double distributive or using FOIL, either way works. If you want to pause it and then check your answer, you're more than welcome to. Okay, so we have negative 1 times 7 is negative 7. Negative 1 times negative 2i, positive 2i, that's out. 6i times 7, positive 42i. 6i times negative 2i, negative 12i squared. Changing that to positive 12. Combining 2i plus 42i gives us 44i's. Bringing down your minus 7, so negative 7. And I just bring the signs down with it. And then negative 7 plus 12 gives me 5 plus 44i. And there's our answer. Okay, next, number 9 and number 10. So number 9, I have negative 5 plus I squared. What we're going to have to do not distribute the square. That is not what it's telling us. What it's telling us is it's negative 5 plus I times itself. And then we have to multiply. So please, you need to rewrite these. You need to rewrite. So it's a square means times itself. Okay, so we have negative 5 times negative 5 is positive 25. Negative 5 times I is minus 5i. That's out. I times negative 5 is minus 5i. I times I is plus I squared. You can change that. So it, because remember this is negative 1, so it is going to be minus 1 here. Negative 5 and negative 5i is negative 10i. Bring down your 25. Again, we're going to do 25 minus 1. So we're going to get 25 minus 1 is 24 minus 10i. Then there we have it. Okay, and number 10, we have 7 minus 2i squared. So we are going to separate that because that means 7 minus 2i times itself. And then we're going to multiply. So we're going to get 49 minus 14i minus 14i plus 4i squared. And then you're right, this is going to become minus 4. We're going to combine our minus 14i minus another 14i. So you have minus 28i, and it's minus, okay? And then I'm going to bring down my 49. Combining 49 and 4, we're going to get 45. So 49 minus 4 gives us 45. I was saying it in red hand. 49 minus 4 gives us 45. And then let's not forget minus 28i. And that's our answer, 45 minus 28i. Now, this video has been 20 minutes. There is a back page. And as we were going through this, I was thinking about how I wanted to do this back page because I did not want this video to go longer than 20 minutes. It takes a while. So I am going to just do what happens to I and then 11 and 12, which are our more advanced examples. And then you saw me cover some work here. I will just quickly run through the other ones. Hopefully I can keep it under 25 minutes. Let's see how I do. Okay, what happens when we raise I to a power other than 1? So we know that I just to the power of 1, that gives us the square root of -1. Okay. We learned today that I squared, we're going to square root, inverse operations. They undo each other, so we're just going to get +1. I to the third. Okay, so how can we break this up? Well, we can do this a couple different ways. So we have to first remember rules of exponents. So we can break this up to I to the first times I to the second. Now, the reason why we can do that is because when we multiply common bases, the bases are I and I. When we multiply, we add the exponents. 2 plus 1 is 3. So we can do that because we know what I to the first is and I squared is. We know I to the first is -1. We could just write it as I. And we know I squared is, we know I is the square root of -1. And we know I squared is -1. So we can rewrite this as I times -1, which means that, and I don't have any space here, I to the third equals -I. Okay. All right, let's do I to the fourth. I to the fourth. All right, so we can break this up. We can go I squared times I squared. Same basis, multiplying. 2 plus 2 is 4. And so we know what I squared is. I squared is -1 times -1. So I to the fourth is +1. We can keep going with this. We could do I to the fifth, I to the sixth, so on and so forth. I'm going to hold off, but I am going to put a little key over here where we see all of the ones that we've done is +1. And hopefully you can start to see a pattern. Okay, and so this would just, you would just get back I. I mean, it just equals I. So it goes I, -1, -I, 1. I'm wondering what the next one would be. We could keep doing this pattern, but again, I want to get to 11 and 12 because I don't want to hold this video very long, so we can cycle back to this, but now I know what happens. Okay, number 11, and I might be doing 11 and 12 underneath here, so if you need an extra sheet, I'm not sure if the spacing is going to be really enough. So number 11, we have 6i times the quantity -5 minus 2i times the quantity -1 plus 4i. So these are your more advanced because we're multiplying more. So let's take it one step at a time. Let's just do 6i times quantity -5 minus 2i. So let's do that first. So 6i times -5 is going to be -30i. 6i times -2i is -12i squared. Okay, parentheses because we still need to bring -1 plus 4i. Okay, now we have this square, so I would definitely change that to a +12, and then we can go through and we can multiply. Okay, so I'm just going to do double distributive here. That's going to be +30i and then -120i squared. That's out. 12, -12, and +48i. Excellent. Okay, so let's change. Yep, this is 30i. let's change this, makes this positive 120 minus 12 plus 48i. We can combine some terms. So let's combine our 120 and our minus 12. And that's going to give us, I feel like oh, whoops, that was plus 120 minus 12. Yep, so that gives us 108. We're good there. And then let's combine our 30i and 48i, and that gives us 78i. And there we have our answer. Okay, and this was number 11. All right, let's do number 12. And again, if you want to try, you're more than welcome to. For number 12, we do see we have 3, 1, 2, and 3. So let's just do the first two. 1 minus 5i, 1 minus 2i. Let's do that first. 1 times 1 is 1, minus 2i, negative 5i, positive 10i squared, and then 1 minus 7i minus 10. So we're going to have negative 9 minus 7i, but we're not done yet because we still have the 6 minus 8i. So you're just repeating yourself here. And I hope that's what it feels like is we're kind of just going through the repetition. Okay, to do this, we get negative 54 plus 72i minus 42i plus 56i squared. Let's change that. Perfect. We can combine those two to get 30i and plus a negative 54. We can combine these two, and we're going to get negative 110 plus 30i, and we're good to go. So I'm speeding up just a little bit because we are doing the same steps. You're multiplying, then you're simplifying your I squared, you're combining like terms, we're multiplying, we're simplifying our I squared, combining like terms, so on and so forth. So if you want to write those down, you're more than welcome to. Now, because we're on 27 minutes, I didn't make it. There are more to this sheet. So what I'm going to do is I am just going to pause here. You can pause it as well. You can try them. You can write them down. Either way works. And then I'm just going to go to that next set. Again, this could be used as a check your understanding. So for that next set, if you did want to pause it, try it and check your answers. You're more than welcome to. There's two more sets, so here's 17 and 18. And being careful with these, 17 and 18, we're not multiplying. We are adding and subtracting, okay? Adding and subtracting, so be careful. So this one, we're going to watch our signs. Are we multiplying or are we adding, subtracting, okay? Be careful. Addition, 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 subtraction. So be careful, okay? Let's see what these next ones are. All right, so 19, here we have its addition and subtraction. Now we're back on multiplication. And the last set, 21 and 22, here we have multiplication. And for 22, we got it all. We got multiplication and we have addition. So you can pause it, check your work, and you have the answers. So our video took a little long, but that is multiplying complex numbers. I hope it helps.